Web HP-Leakage Detector is the simplest system for managing water leaks in the aqueduct. To frame the problem, we must ask ourselves why it is essential to have a leak management tool, an active leakage control system. Firstly, it must be considered that water is often a scarce resource and therefore losses must be reduced. In particular, energy was used to produce the dispersed water and purification was carried out. This generates waste. Leaks in the pipes must, sooner or later, be repaired, and this generates costs that must be managed efficiently. To reduce leaks, however, I have to quantify the leaks in each district, evaluate the daily variations to intervene urgently on the most critical situations, then be able to rationally and objectively evaluate the priorities of leak search and repair. Then it is finally necessary to verify that the repairs have been effective, or that they have produced stable reductions in leaks. All this can only be done with a good ALC system. Let's now see the features and benefits of the HP-Leakage Detector web software service. First of all, thanks to its innovative algorithm, the service is very easy to use because it does not require, like other products, continuous calibration of the parameters of the districts. It allows daily calculations of losses, allowing you to prioritize leak detection and repair activities across districts. Manages performance indicators such as leak value per kilometer of network. Calculate loss statistics. It automatically performs the diagnostics of the measurement data, thus validating the processing performed on the leaks. Finally, it automatically reconfigures some operating parameters, especially those for self-diagnostics of measurements. Currently, Web HP-Leakage Detector manages the losses of the distribution network, but in a future version it will also manage those of the supply network. Now let's see the architecture of Web HP-Leakage Detector. Web HP-Leakage Detector is a system that works connected to an external system, the green one in the figure, which feeds it with the necessary inputs. The external system can be an enterprise system of the water operator, the remote control center, or a water management system, or another third-party software service. It must feed daily, but potentially at different times in order to manage multiple time zones. Web HP-Leakage Detector with all the incoming and outgoing water flows from the various districts managed, a sample every quarter of an hour. In response, Web HP-Leakage Detector can provide the external system with all the leak calculations through an interface to be built ad hoc, case by case. Alternatively or simultaneously, Web HP-Leakage Detector has its own operator interface to return data on a PC or mobile device, also allowing you to download summary documents in the form of CSV archives. Let's see a part of the functionality of the system, examining perhaps the most significant screen, namely the one summarizing the data of a single district on a given day. In the highest part of the screen we have the indicators of loss per kilometer. The actual one is the one that was set as a goal, and the percentage loss data. As you can see, there is a selector that allows you to select the day you want to examine. In the central part we have all the analytical data of loss, input, annual economic value of the loss if the loss detected on the selected day is replicated for 365 days. You can see the HP index, which is an indicator that allows you to define the priorities of intervention to search for and repair leaks, and finally the economic value of the water per cubic meter, which allowed us to calculate the economic value of the leak detected on the chosen date. Finally, we have a graphic trend, which at this time is selected on a monthly basis, in which the daily losses of the district are compared with a threshold defined by us. If you examine this diagram you can see that in the last few days the losses have grown continuously until they exceeded the alarm threshold, as also indicated by an alarm icon. However, the red dot you see on the left of the screen indicates that, on the day examined, a technical anomaly has occurred. Finally, let's look at the lower part of the screen. In it we see in blue the trend of the flows in the 24 hours of the day examined, together with the averages of the 15 days before and after the day itself. As can be seen on this day, an anomaly occurred around 9 a.m. This anomaly has suddenly raised the flow rate of the district to very high levels. So it is certainly a pipe break or an incorrect maneuver on a gate valve or a serious failure of a flow meter. This fact is diagnosed immediately by the internal self-diagnostic system, which classifies the day as a day not validated from a technical point of view and urges timely maintenance intervention. At the bottom of the screen we have two buttons. One allows us to export all the data on the screen to a CSV archive. The other allows us to go back in navigation, to examine no longer the data of a single district, but the data of an area of districts, or of the entire water management agency. Finally, we see in this figure, by way of example, an integration of the product with an external system, the Software as a Service WebLS by Locroix Sofrel. WebLS sends flow data to Web HP-Leakage Detector via CSV archives, which are sent via FTP to a network folder. The data are consulted by the WebLS user, through links, which are shown on the cartography, designed to call up the web page containing the data of the various districts. For more information about our solution and for a demo, please contact us at the email address shown here.